Hi all, welcome to my lecture on specific speed of a centrifugal pump. Specific speed of a centrifugal pump. Represented by N S. So the specific speed of a centrifugal pump is defined as the speed of a geometrically similar pump which would deliver 1 cubic meter of liquid per second against a head of 1 meter. So the expression for specific speed, we know that the discharge for a centrifugal pump Q is equal to discharge of a centrifugal pump Q is equal to area into velocity of flow. Velocity of flow. That is, area is equal to pi d into b into velocity of flow Vf, where d is the diameter of the impeller of the pump and b is the width of the impeller. So Q is directly proportional to pi is a constant d into b into Vf, and we know that b is directly proportional to d. Therefore, Q is directly proportional to d square into Vf. Again, we know that the tangential velocity is being given by the equation u is equal to pi dn by 60. That is, u is directly proportional to d into n. Now again, we know that the tangential velocity u is equal to ku into root of 2ghm, where ku root of 2g are constant, therefore which implies that u is directly proportional to root of h into m. Therefore dn is directly proportional to root of hm. Therefore d is directly proportional to square root of hm divided by n. Now substituting this value, so mark it as equation number 1 and this as equation number 2. Substitute the value of equation number 2 in equation number 1. So therefore Q is directly proportional to substituting this value hm by n square into Vf. Q is directly proportional to hm into n square by Vf. Sorry, Q is directly proportional to hm by n square into Vf. Now, velocity of flow Vf is equal to Kf into root of 2ghm. So Kf and root of 2g are constant, therefore Vf is directly proportional to root of hm. So we will get the relation u is directly proportional to Vf, which is directly proportional to root of hm. Mark this as equation number 3, and substituting the value of equation number 3, mark it as equation number 4 and this as equation number 3. So substitute the value of equation number 4 in 3. Therefore Q is directly proportional to hm by n square into root of hm, which implies that Q is directly proportional to hm into hm raised to 1 by 2 by n square. Therefore Q is directly proportional to hm raised to 1 plus 1 by 2. by n square, which implies Q is directly proportional to hm raised to 3 by 2 by n square. Q is equal to a constant K into hm raised to 3 by 2 by n square, and K is a constant of proportionality. And if hm is equal to 1 meter, Q is equal to 1 meter cube per second, therefore n becomes ns. N will become equal to ns. Therefore, substituting these values, therefore Q is equal to K into, the value of Q is 1. Therefore, 1 is equal to K into hm is equal to 1 raised to 3 by 2 by n become ns square. Therefore, K will become equal to ns square. Now substitute the value of K in this equation for Q. Therefore, Q is equal to ns square into hm raised to 3 by 2 by n square. So we need the equation for ns. Therefore, ns square is equal to n square into Q divided by hm raised to 3 by 2. Therefore, ns is equal to n root q divided by hm raised to 3 by 4, taking the square root. So this is the equation for specific speed of a centrifugal pump, n root q hm raised to 3 by 4. So specific speed of a centrifugal pump as the speed of a geometrically similar pump, which would deliver 1 cubic meter of liquid per second against a head of 1 meter. So this is the equation for specific speed of a centrifugal pump. Thank you.